everyone, I'm Anne, and today we're going to set up an experiment to find out how ocean acidification impacts shell-building organisms like urchins, sea snails, and oysters. So to quickly review, climate change is caused by increasing amounts of carbon dioxide and other greenhouse gases in the atmosphere, and some of that carbon dioxide is absorbed into the ocean. It's like a giant sponge. And as the carbon dioxide dissolves into the ocean water, it causes the ocean to become more acidic. So to find out how this impacts shell-building organisms, we're going to be testing out some oyster shells in these jars with various conditions. We'll make some visual observations and then we'll weigh the shells before and after the experiment to see how they fared under these different conditions. My first jar over here is a control, so it just has water in it. And the other jars have various concentrations of vinegar, which is very acidic, so we're using it to mimic ocean acidification. This jar has 25% vinegar in it, the other 75% is water. This jar is half and half, so half vinegar, half water. And this jar over here is 100% vinegar. And let me tell you, it smells great. So for each of these conditions we'll be testing, I'm going to weigh the shell that we'll be testing and measure the pH of the liquid inside the jar, and then we'll do the same thing after the experiment. So let's weigh the shell. And I'm taking the mass in grams here. Let's move on to our 25% condition. So let's take a look at all of our data one more time. Okay, we're ready to drop in our shells. So as I do that, see if you notice anything starting to happen with these shells in the jars right away. What do you notice? Let's start with our control. All right, our 25%. Moving on to our 50%. Let's make sure these lids go on. All right, and our 100% condition. So we're going to go ahead and leave these shells in their jars for at least 24 hours and then take them out and let them dry for a few days before taking our final measurements. What do you think will happen to these shells over the next few days? Okay, we let the shells soak in their solutions for about a day and a half, And then we took them out and they've been drying in the sun for the past few days, so I think we're ready to take our final measurements. But before we do that, let's take a look at the shells themselves. If I pick up my control condition over here, it looks like the shell looks and feels pretty much the same as it did when I first put it in the jar, which is what you might expect from a control condition. The other shells, it might be hard to see on film, but they've actually lightened a little bit. They sort of bleached out sitting in those vinegar solutions. And this shell over here that was in our pure vinegar condition, when I first took it out of the jar, it was really soft and pliable. It was almost like rubber. And now that it's dried out, it's become really fragile and brittle and kind of flaky. And I'm having to be careful as I hold it here not to let too much of it break off, because we still need to weigh these shells to complete our experiment. Let's go ahead and weigh each of the shells and take the pH of the jars again. So here's my control. Let's take this one. Let's take a look at all of our data one more time. So now what I've done with our data is I went ahead and calculated the percentage change in shell mass for each of these conditions. So for example, if one of our shells was now half the mass that it was before we started the experiment, that would be a 50% decrease in shell mass. So let's see what happened in each of our conditions. Now in our control condition, we actually had a slight increase in shell mass, a 2.4% increase. It's really unlikely that the shell actually grew inside the jar, right? More likely what happened is that there's still a few of those water molecules that haven't completely evaporated, even though we spent quite a while drying out this shell. So a slight increase in our control condition. In our 25% condition, we had an 8.3% decrease in shell mass. So a little bit of mass was lost as this shell soaked in the solution. For our 50% condition, we had a 9.1% decrease. So a little bit more of a decrease than our 25% condition, but not by much. Now in our 100% vinegar solution, the shell actually lost 54.5% of its mass. So that means that this shell is now less than half of the mass that it was before we started the experiment. You can see that there's a relationship between pH and change in shell mass. The shells that were in more acidic conditions disintegrated more. They lost more mass compared to the shells that were in less acidic conditions. Now there are clearly some differences between these lab conditions and real-world conditions out in the ocean, but this lab still gives us some idea of how ocean acidification might impact ocean life. So let's revisit our investigation question. How does ocean acidification impact shell-building organisms? How would you answer this question based on the experiment we just completed?